Okay, if you try to work through problem number 8 yesterday, this is very similar to problem number 8. An inverted conical tank is being filled with water. Tank is 24 feet tall. This is good. This is good. All right, for YouTube Nation, we were comparing sneezes. There are a few sneezes. I won't identify whose. Somebody sneezed. Sounds like a fart, apparently. Thankfully, the sneeze does not smell like a fart. So, all right, here we go. True or false? The height of the cone is changing. False. True or false? The base of the cone is changing. False. You see, we have the water. So the water assumes the shape of the cone. And a lot of people will mistakenly plug in some information to the formula that's going to lead them down the wrong path. So again, I have to focus on the shape of the water, not necessarily the shape of the cone. Volume is equal to 1/3 pi r squared h. I know V prime. What is V prime? 10. True or false? The radius of the water is changing. True. True or false? The height of the water is changing. In fact, that's what we're trying to find is h prime. We do know the current radius of the water. What is the current radius of the water? 6. This is the diameter. Oh, I'm sorry, folks. I gave that the wrong label. The diameter of the cone is 20. Okay? So, yes, the radius of the water at this time is 6. So we want to find the rate at which the height is increasing. Right now, if I were to take the derivative, what rule would I have to use? I'd have to use the product rule. And if I use the product rule, will I come up with an h prime? Yeah, will I come up with an r prime? But I don't want an r prime because I don't know what r prime is. So therefore, I have to insert something. This is where I use my tricky kind of relationship from yesterday. Namely that I want r over h. What is the radius of the cone? 10. What is the height of the cone? 24. So the water, as it accumulates in the cone, will always maintain that proportion, that relationship. And so I know that 24R is equal to 10H, or R is 5 over 12H. So now I can go back to my formula for volume. Volume is 1/3 pi times 5 over 12 h quantity squared times h. Every year I get students who at that point will try to take the derivative. Don't. If you try to take the derivative right now, you'll have to use the product rule with the chain rule. Just square this out and then multiply by h. So we get the volume is equal to 1 over 3 pi times 25 over 144 h cubed. Or volume is equal to 25 pi over 3 times 144 is 432 h cubed. So now I'll take the derivative with respect to time. What is the derivative of volume? V prime equals, I'm going to drop that 3 in front, make it 75 pi, or 432, h squared, h prime. Now I need to figure out what h is. Do I know the current height of the water? No, what dimension do I know about the water? The radius is 6. So I have this. 6 is equal to 5 over 12 h. Can I use that to find the height? Multiply by the reciprocal, and height is then equal to 72 over 5. I'm going to multiply by 12 over 5 to get rid of that. 6 times 12 is 72. This. I'm going to come up with a decimal here. I have 75 pi divided by 432 times parentheses 72 divided by 5 squared. I get V prime is 10 is equal to 113.1 H prime. So H prime is 0.088 what? Feet per minute. I'd say for most students that's kind of one of the most challenging problems that they see in the notes. We get to our last example, which is another. There's so many different related rate problems. I just tried to choose the ones that are most popular over time that I've seen in AP exams and stuff like that. So we get to our last one. We have a street light. Smaller on pole. We got a man in front of it. He's 5 feet tall. Lamp pole's 20. Says he's walking away from the pole with a speed of 4 feet per second on a straight path. So how fast is the tip of his shadow moving when he's 30 feet from the pole? Do you think the length of his shadow is changing? Yeah. Do you think his distance from the pole is changing? Yeah. So I'm going to call that D. I'm going to call that S. D for his distance from the pole. S for the length of his shadow. Now we do know that D currently is 30, but what we don't know is we don't know the length of his shadow. We don't know the rate at which the shadow is moving away. So I need something. I need a formula. Who's got something for me? Yes, proportions. Thank you. Close. 5 over S is equal to 20 over D plus S. Now, if I were to take that derivative, what rule would I have to use? quotient. I don't really like that idea. So what should we do instead? Cross multiply. 20s is equal to 5d plus 5s, or 15s is equal to 5d. Or in other words, 3s is equal to d. That's a lot easier to take the derivative of, right? What is the derivative of 3s? Derivative of d? So 3s prime is equal to d prime. I need to know s prime. Do I know d prime? 4. He's walking at a rate of 4 feet per second away from the shadow. So, 3 s prime is equal to 4. So s prime is equal to 4 over 3 feet per second. Unfortunately, this is not the final answer. That's just the rate at which his shadow is moving away from him. Have you ever been to the airport? Been to one of those walking escalators? So if I'm walking on one of those, if I'm on one of those walking escalators, and let's say that the escalator is moving at a rate of 1 foot per second, then my rate is 1 foot per second. Suppose I'm walking on the escalator at a rate of 2 feet per second. What is my total rate? 3 feet per second. So you can see that we have the shadow is moving at a rate of 4/3 feet per second away from the man. But he is also moving 4 feet per second away from the light pole. So if it said how fast is the tip of the shadow moving away from the man, then we would want the 4/3. But the tip of the shadow is actually moving at a rate of 4 plus 4/3. So 16 over 3 feet per second. Does that make sense? So the speed is relative to the object that you're working with. So, all right. So, so far what I have assigned to you is on your list of problems. I've assigned to you 1 through 12 so far, and 16 and 18, right? I would like you to also do 14. And then choose 3. I will warn you that problem 13 is not easy. Problem 13 is not easy. Problem 19 and 20 are awesome problems, but they're not easy. So far, in the problems I've given you, I've modeled the problem just about exactly like all of them. I want you to try 3 that you haven't seen exact examples of. I gave you a study guide already, right? I'm going to give you all day tomorrow to work on your homework and get started on a study guide if you'd like. You have the rest of the hour today. You have 6 minutes here before lunch. Have at it, folks.